Okay, today we are going to continue our conversation about parallel and perpendicular lines. All right, before we hop into our particular topic of the day, let's review parallel lines quickly. Remember that two lines are parallel if they have the same slope and different y-intercepts. And that when we say lines are parallel, what we were saying is that they are two lines that will never intersect. Now, looking at our two equations on the slide here, we can see that the first line has a slope of 3, the second line has a slope of 3. The second line has a y-intercept of -9, and if we were to distribute and combine like terms here, we would see that we have a y-intercept that is not -9, which implies that we have two different lines. We can also do this graphically. Graphically is a little bit easier because we can definitely see that they have two different y-intercepts, and then we can do our rise over run, so up 1 over 5, up 1 over 5 to confirm that they do have the same slope and will not intersect. Now, what we are going to do today is write equations of parallel lines when given one line and a new point that we want the second line to go through. Now, if we think back to our prior lessons, when we write the equation of a line, all we need is a point on that particular line, which will be given to us today, and the slope of that line. So if we want our two lines to be parallel, then we must find the slope from the first equation. All right, and depending on the form, that's easy or difficult. All right, and then use that in our second equation so that they will have equal slopes and different y-intercepts. So if we take a look at some example problems here, all right, so if we look at our first one here, all right, we want our new line to be parallel to y equals -3x minus 8, which means that for them to be parallel, we want to have the same slope. And then we want our new line to go through 4, 1. So we need a slope of -3, and we need our new line to go through 4, 1. So if we remember, we talked about point slope form, which is m times the quantity x minus x1 plus y1. And I just need to take all my given information and substitute for the appropriate piece. So m is -3. We have x minus x1, which is 4, and then plus y1. And so what we have now is a second equation that is, in fact, parallel to the first line and goes through our new point. All right, we can leave it in this form unless we need to do more work, depending on the directions of the problem, but this is a very acceptable form of our line. Okay, looking at number 2 here, we can see that the slope of this line is 4. All right, we want to go through the point -2, 4. So once again, we're going to use point slope form, all right, to write the equation of our parallel line. So since we want our lines to be parallel, we want to have the same slope of 4. Now notice in this case, it's x minus x1, so I'm subtracting a negative number, therefore this is going to become a +2, and then this is plus 4. All right, so if the equation is in slope-intercept form, it's pretty simple. We can see the slope is right here. We can take that slope and jump right into writing our equation. However, occasionally we will have equations that are in standard form, and so we may have to do a little bit of manipulation prior to writing our equation so we know what the slope is going to be. So what I'm going to do now is convert standard form to slope-intercept form. So the first thing I'm going to do is move our x term to the right-hand side by adding 5x. So 10y equals 5x minus 30. And then I'm going to divide by 10. Now, when I do this, I have converted my standard form equation into slope-intercept. And the reason we want to do this is because now, okay, we can see the slope is 1/2. And so we can jump right into our point slope form. We need the same slope for our line to be parallel. I need to subtract my x coordinate of my new point, which is 5, so x minus 5. And then we have our y coordinate on the outside. And so here's our parallel line. So if it's in standard form, we have to do a little bit of pre-work in order to find the slope that we would want for our new line. Now let's look at two other examples here. One is if we have a horizontal line. So remember, everything in the form of y equals b is horizontal. So if we want our line to be parallel to a horizontal line, we need another horizontal line. So if this is y equals 5, I just need y equals. And so what I'm going to look here is at my point and find my y coordinate. Okay, there's x, there's y, so I just want this to be y equals 3. So horizontal line that goes through 0, 5, horizontal line that goes through 0, 3. In a very similar fashion, okay, if we look at number 5, we have a vertical line. Well, the only type of line that is parallel to a vertical line is another vertical line, so we need another x equals. And then once again, I just have to look at the given point, figure out what my x value is, and then use that for my equation. So x equals 8. And so these two lines would in fact be parallel. Okay, so what I would like you to do right now is work out these 5 example problems on your own. So go ahead and pause the video. All right, go ahead and write a line parallel to each of these through the given point, and then turn the video back on and see how you did. Okay, so here are the answers to the example problems. All right, number 6 should be y equals 3/2 times x minus 8 minus 5. Number 7 should be y equals negative 3/5 times the quantity x plus 8 plus 3. Now number 8 is once again an example of something in standard form, so you had to solve, all right, for y, get it in slope-intercept form. We can see that, all right, our slope was 1, so the answer should be y equals 1 times the quantity x minus 9 plus 1. Number 9, horizontal line, so we need another horizontal line, y equals 3. Number 10, we have a vertical line, and we need another vertical line, so x equals 5. And so that's really all you need to be able to do to write the equation of a line parallel to a given line and through a given point. So what we want to do now is talk about, well, okay, what do we do for perpendicular lines? All right, and so just to review quickly, all right, remember, perpendicular lines have opposite and reciprocal slopes, so 2/3, negative 3/2. All right, and perpendicular lines are lines that intersect at right angles. So once again, it's going to be a very similar process, all right, to what we did with parallel lines. All right, so we're going to have to find the slope of our first line, and then we're going to take the opposite and reciprocal of that slope in order to write our new line. All right, so once again, we're just going to kind of repeat the process that we did with parallel lines, except for instead of having the same slope, we need opposite and reciprocal slope, all right, to have our lines be perpendicular. All right, so let's just jump right into some examples here. All right, so once again, very similar look to what we just did. All right, now the good news is, all right, the process is almost exact. Now, if we look at number 1, the slope of this line is negative 3, and I'm going to make sure that we remember that every whole number is over 1. So the slope of our new line, if we want it to be perpendicular, has to be the opposite. So since it's negative, our new slope has to be positive. And then the reciprocal of 3 over 1 is 1/3. And then once again, I just take my new slope, the given point, and I am going to plug it in to our point slope form, and we're finished. So there's not much difference in the work, except for we have to think a little bit more about opposite and reciprocal, all right, to make sure we have the appropriate slope. So on number 2, the slope of our given line is 4. So the slope that we would want would be opposite and reciprocal of this. So since this is positive, we would now want our new slope to be negative, and the reciprocal of 4, all right, remember that every whole number is over 1, is 1/4. And then I would take this and plug it into our point slope form. Now once again, I'm subtracting a negative here, so that's going to become a positive, and then plus 4. And so our new line is perpendicular to our given line. All right. Now, once again, we may have to do a little bit of work here. All right, if it's not in a form where the slope is recognizable immediately. So I'm going to go ahead and just convert this to slope-intercept form very quickly, just like we did a few slides ago. So I'm going to add 5x to both sides, then divide by 10, and we get the line, okay, y equals 1/2 x minus 3. So the slope of this line is 1/2. Okay, so the new slope needs to be the opposite and reciprocal, so that's going to become a negative 2 over 1. And then I can just jump right into point slope form. And so there's our perpendicular line. Now, for examples 4 and 5, all right, we can think about this a little bit more conceptually. Once again, y equals 5 is a horizontal line. So y equals 5 is horizontal, looks something like this. Well, the only type of line that is perpendicular to a horizontal line is a vertical line. That gives us a right angle. So all vertical lines have a form of x equals a. So once again, I know if this is y equals, this has to be x equals, all right, in order to go from horizontal to vertical. And then I have to look at my point. All right, so it has to go through 4, 3, so x would have to equal to 4. And it's just the opposite on number 5. All right, we start with a vertical line, okay, x equals negative 3, and the only line perpendicular to a vertical line is a horizontal line. There we go. All right, so that means we need a y equals. And then once again, I go to my point, y equals 2. Okay, so you can see that the process is very similar for the two ways for parallel and perpendicular. So once again, I'd like you to go ahead and pause the video, all right, write the equation of a line that's perpendicular to the given line and through the given point, and then turn the video back on and check your answers. Okay, so here are the answers that you should have come up with for these 5 problems. So you can see the answer to number 6, the answer to number 7, the answer to number 8, the answer to number 9, and the answer to number 10. So hopefully you did very well on this. All right, so this really wraps up, all right, this lesson. All right, so right now you should be able to come into class and be ready to jump into our classwork and the homework for this assignment.